there, this is Mathematics Alive, Geometry Lesson 7, Pythagorean Theorem, Proofs and Applications. Given its long history from the ancient times, there are more than 350 proofs of the Pythagorean Theorem. In this lesson, I will be presenting 3 simple proofs of this theorem. Pythagorean Theorem is one of the most useful theorems in geometry. It was named after Pythagoras of Samos, who is believed to have given the first proof of the theorem around 500 years before Christ. However, the Babylonians knew this theorem and its applications about 1,000 years earlier. In any right triangle, the square of the length of the hypotenuse is equal to the sum of the squares of the lengths of the other two sides. So here is the geometric representation of the Pythagorean theorem. Proof number 1, the Pythagorean puzzle. We need the following materials: 8 congruent isosceles right triangles of the same color, and 1 isosceles right triangle of different color. We need to form a square on each side of the pink triangle using the 8 congruent isosceles right triangles. And this is the result. By observation, we know that the square on the hypotenuse is equal to the sum of the squares on the legs of the pink triangle. Algebraically, we express it as the Pythagorean theorem: c squared is equal to a squared plus b squared. This is proof number 2 of the Pythagorean theorem. Materials needed are 4 scalene right triangles cut out with sides A, B, and C, and 1 square with sides equal to C. We need to form a big square around the red square, and the area of the big square is equal to B plus A quantity squared, or A plus B quantity squared. Next, we remove the red square from the figure A, and the resulting figure is the figure on the right. So we have here the equation. The area of the big square minus the area of the small red square is equal to the area of the 4 right triangles. So algebraically, we represent the area of the big square, A plus B quantity squared minus C squared, is equal to the area of the 4 triangles, so 4 times 1/2 AB, and then we subtract AB from both sides. So the resulting equation is A squared plus B squared minus C squared is equal to 0, and then we add C squared to both sides to get the final result, which is C squared is equal to A squared plus B squared. The Pythagorean theorem is proven. Number 3 is Pythagoras proof. Pythagoras proof is a purely geometric demonstration using 2 congruent squares. Square 1 is composed of 4 triangles and 1 big square, which is C squared. Square 2 is composed of 4 triangles and 2 smaller squares, which is A squared and B squared. Remove the 4 triangles from the 2 squares and we have these squares left. Since we have removed equal areas from equal figures, the difference are also equal. Therefore, C squared is equal to A squared plus B squared. Now let's go to the applications of the Pythagorean theorem. The simplest Pythagorean triple is the 3, 4, 5 triangle. Forming squares on each side of this triangle, we can observe that the sum of the areas of the squares on the two legs is equal to the area of the square on the hypotenuse. Now let's look at these word problems to apply our Pythagorean theorem. Number 1, how high is the window of this building if a wooden ladder 13 meters long leans on its base and the foot of the stair is 5 meters from the building? Solution. Given C is equal to 13 meters and B is equal to 5 meters, then find A. C squared is equal to A squared plus B squared can be manipulated, and the resulting equation is A squared is equal to C squared minus B squared. So solving for A, we have A squared is equal to 13 squared minus 5 squared, and we get A squared is equal to 144. Then A is equal to the square root of 144, which is 12 meters. Number 2, given another ladder which is 13 meters and it leans on a wall 12 meters high. How far is the foot of the ladder from the base of the wall? So we're going to solve for B, the base, and we use the formula B squared is equal to C squared minus A squared. Solving for B squared, we have 169 minus 144 is equal to 25, and B is equal to the square root of 25 or 5 meters. Number 3, the distance from the tip of this pine tree to the tip of its shadow is 4 meters. The length of the shadow of the tree is 2.5 meters. How tall is the tree? Solution. Given C equals 4 meters and B is equal to 2.5 meters, find A. So use A squared is equal to C squared minus B squared. Then plug in the given values. So we have A squared is equal to 4 squared minus 2.5 squared. And we get A squared is equal to 9.75, and the square root of 9.75 is 3.12 meters. That's the value of A and the height of the tree. Number 4, an isosceles triangle has a base of 16 centimeters and an altitude of 6 centimeters. What is the length of one leg of this isosceles triangle? Solution. We just take a half of the triangle and you have a right triangle and find the value of C. So we have C squared is equal to A squared plus B squared. So we get the value of C. C squared is equal to 6 squared plus 8 squared is equal to 100. The square root of 100 is equal to 10. So the value of C is equal to 10 centimeters. Pythagorean theorem has so many other applications. As long as you have a right triangle and two sides are known, you can solve for the missing side. In my next video, I will be discussing about proving right triangle congruence. Please don't forget to like, share, and subscribe to this channel by clicking the button below. Bye-bye for now. God bless.